Welcome to Math 1960. This is Calculus 2. Um, Today we're going to discuss about Taylor series, Maclaurin series. We'll discuss about the divergence of the Taylor series. We will find expansion of both Taylor series and Maclaurin series. So a Taylor series is we can find a Taylor series to a function that have derivative of all orders. So if you have a function f of x between the region c minus r and c plus r, where r greater than 0, if it has a derivative of all orders, then we say that we can find the Taylor series. So the Taylor series of a function would look like this. Unlike the Maclaurin series, Taylor series centered at C, Maclaurin series centered at 0. So they are the same pretty much. So here we want to find the expansion of these. So we want to find a Taylor series out of e to the x. So first of all, the formula says, so the Maclaurin series formula says f of x is going to be equals to f of 0 plus f prime of x, f prime of 0, sorry, f prime of 0 times x divided by 1 factorial plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x to the third, and so forth, up to f, the nth derivative of f of 0 over n factorial x raised to the power of n. So so right now we're going to find these different terms, f of 0 and so forth. So what is my f of x? My f of x is e to the x, and then f of 0, it's going to be equals to 1. F prime of x is equal to e to the x. F prime of 0 is equal to 1. So f double prime of x is equal to e to the x. F double prime of 0 is equal to 1. F triple prime of x is equal to the e to the x. F triple prime of 0 is going to be equals to 1. So then the Maclaurin series of this function would look like this. F of x equals to 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4th factorial plus x to the n over n factorial plus up to infinity. So that is the Maclaurin series of that. So now we want to discuss the conversion of a Taylor series. So a Taylor series can be written as or any function that has Taylor series can be written as f of x equals to r of n, okay, plus p of n. R of n here is known as the remainder after we got the p of n. So p of n here would be like Taylor polynomial. So this r of n, if this r of n is equal to 0, then we say, according to the theorem, that this this function here converges. Okay, so here we are going to discuss two scenarios. First, in order for a function to converge, we find limit as n goes to infinity of what? Of this type of function, f of so the n plus 1 derivative of f of u times x raised to the power of n plus 1 over n plus 1 factorial. If the limit here is equal to 0, then we know that this function converges. Okay, so this function here, this is a Maclaurin series. So first of all, we are going to say we have, let's say the u, this problem that makes it harder is u here. So say here we have u, which is between x and 0. That means e of u here, using the function here, going to have 1 less than e to the u less than e to the x. And then if we multiply both sides by this quantity, we're going to get x raised to the power of n plus 1 over n plus 1 factorial less than e raised to the power of u times x of n plus 1 over n plus 1 factorial less than e to the x x raised to the power of n plus 1 over n plus 1 factorial. So when we take the limit of this, we get a 0. When we take the limit of this, we get a 0. And then therefore, according to squeeze theorem, this one also would be a 0. And then because we don't know u, so that's why we don't mess with this. The same thing, if u is in between say 0 and say x, okay, we just do the same thing here. We're going to get e to the x x raised to the power of n plus 1 over n plus 1 factorial less than e raised to the power of u x raised to the power of n plus 1 and n plus 1 factorial. And here we're going to get x raised to the power of n plus 1 over n plus 1 factorial. So if we take the limit of this n here, we get a 0. We take the limit of these, we get a 0. That means that the r's of n converges. And if r's of n converges, that means the function converges. Okay, so here we want to find the expansion of this type of function. So to find the expansion for sine of x, we use the Maclaurin series, so no need for repeating ourselves. So here we're going to say f of x is equal to sine of x, and then f prime of x is equal to cosine of x, and then f double prime of x is going to be equal to negative sine of x, and then triple prime of x going to be equal to negative cosine of x. So here when we say f of 0 equal to is equal to 0, f of f prime of 0 is equal to 1, f double prime of 0 is equal to 0, f triple prime of 0 is equal to negative 1, and then the Taylor series according to the Maclaurin series according to that sine of x is equals to x minus x cubed over 3 factorial plus x raised to power 5 divided by 5 factorial minus x raised to power 7 over 7 factorial plus n of x raised to power of n of 2n plus 1 raised to power of 2n 1 factorial. So this is how it's going to look like. So to do cosine of x, so we know like cosine of x is nothing but d over dx of sine of x. And so doing the derivative of the cosine of x, we are going to get the following. So this would be d over dx of x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial, and so on. So if we do that derivative, we should get 1 minus x squared over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power of 6 over 6 factorial, and so forth. So to do for sine 2x, so we use the same method. So sine 2x would have the following. It's going to be 2x minus 2x raised to power of 3 factorial plus 2x raised to power 5 over 5 factorial minus 2x raised to power of 7 over 7 factorial and so forth. Okay, so here we want to find this regarding like this is a Taylor series this time. We've been doing a Maclaurin series, so the Taylor series of that is going to be f of x, f of c here is going to be pi, c is going to be pi over 2, so f of c plus f prime of c x minus c plus f double prime of c x minus c is f minus c squared, and f triple prime of c x minus c cube over 3 factorial, and so forth. So here when we find f of x, it's going to be cosine of x, and then f prime of x will be negative sine of x, and then f double prime of x it's going to be